Okay, the question says, solve the following simultaneous equations. Y minus 3 equals x, and x squared plus xy plus y squared equals 21. So to solve them simultaneously, that means find one or more pairs of xy values which will satisfy both the first equation and the second equation. Okay, we're going to do this by substitution. So first of all, I'm going to label my two equations 1 and 2. And then we're going to notice that the first one is already in the form x equals some function of y. So I'm going to substitute x equals y minus 3 into the second equation that we've been given. So what that means is every time I see an x, I'm going to replace it by y minus 3 because that's equivalent. So we're going to have y minus 3 squared instead of x squared. Then we're going to have y minus 3 times y instead of x times y. And then we're going to have y squared. And that's all equal to 21. So let's tidy this up and solve it, because I've now got one equation with just one unknown in it, which is the y. So if I multiply this out, I'll have y squared minus 6y plus 9 from that first quadratic term. Then I'll have plus y squared minus 3y from the second term, and then I've got plus y squared on the end equals 21. Let's collect like terms. So I'm going to have y squared plus y squared plus y squared, so I have 3y squared minus 6y minus 3y, which is minus 9y, and then I've got 9, and if I bring the 21 over by subtracting 21 from both sides, I'll have minus 12, and that's equal to 0. Before trying to factorise this, something that's going to help us out is to notice that there's a common factor of 3 in every term. Because it's equal to 0, if I divide by 3, 0 divided by 3 is still 0. So I can say that y squared minus 3y minus 4 is equal to 0. Staring at this a bit, we can factorise it as y minus 4 times y plus 1 equals 0. And so the two values of y which satisfy this equation are when y is 4 and when y is minus 1. Right, so we've now got two y values which are the first part of our solution to the simultaneous equations. The next thing to do is to get the corresponding x values, which we're going to get by substituting into the first equation. So y equals 4 tells me that x is going to be 4 take away 3, which is 1, and y equals minus 1 tells me that x is going to be minus 1, minus 3, which is minus 4. So my two solutions are x equals 1, y equals 4, those two values going together, and x equals minus 4, y equals minus 1. And it's important to remember that if I were to sketch these two curves, in the first case it's a straight line, in the second case it's an ellipse, then where they touch, their intersection points, are precisely these pairs of coordinates. And I'll stop there.